Welcome to the Hodja on Everything. The Space. Chapter 8, The End as We Know It. In the previous episode, we imagined civilizations capable of harvesting the energy of entire planets, stars, and even galaxies. The Kardashev scale invited us to think on truly extraordinary scales. But no matter how advanced a civilization becomes, there is one negotiation it can never win. Time always has the final word. Today we discover that even the greatest civilization imaginable cannot negotiate with time. Stars age, galaxies change, even the universe itself may not last forever. Fortunately, before anybody begins canceling holidays or updating their will, I should point out that everything we discuss today unfolds over billions or even trillions of years. You may safely finish today's cup of coffee. Our story begins with a star we know rather well. The Sun has served the solar system faithfully for about 4.5 billion years. It has never taken a holiday, never called in sick, and has maintained a remarkably impressive attendance record. Every second, it quietly converts hundreds of millions of tons of hydrogen into helium, producing the light and warmth that make life on Earth possible. Like every successful employee, however, even the Sun is slowly working its way towards retirement. Stars shine because gravity constantly squeezes their cores while nuclear fusion pushes back outward. For billions of years, those two forces exist in a delicate balance. Gravity pulls inward, fusion pushes outward. It is less like a battle and more like two colleagues who have worked together for so long that neither quite remembers whose job is whose. Eventually, however, the hydrogen fuel in the Sun's core will become exhausted. Fusion will slow, gravity will briefly gain the upper hand, and the core will begin to contract. That contraction raises the temperature even further, allowing new types of fusion to begin. Rather than dying quietly, the Sun will respond by growing dramatically larger. Astronomers call this stage a red giant. Humans occasionally respond to aging by buying sports cars. Stars prefer expanding to hundreds of times their original size. Mercury will almost certainly disappear. Venus is unlikely to fare much better. Earth's future, however, is a little more complicated. Even if our planet escapes being swallowed completely, the increasing heat will boil away the oceans long before then, strip away the atmosphere, and leave the surface entirely uninhabitable. Property prices, one suspects, will fall rather sharply. Fortunately, none of this is expected to happen for around 5 billion years. If you had plans for next Tuesday, I would keep them. In the end, the Sun will shed its outer layers into space, creating a beautiful glowing cloud known as a planetary nebula. The name is rather misleading, as planets have almost nothing to do with it. Astronomers in the 18th century thought these objects looked vaguely like planets through their telescopes, and the unfortunate name simply refused to retire. At the center, all that remains is a white dwarf, an Earth-sized stellar core that will slowly cool over trillions of years, quietly fading long after the rest of the solar system has changed beyond recognition. For our own little cosmic neighborhood, that is the end as we know it. But the solar system is only one tiny corner of a far larger universe, and once we begin asking how the universe itself might end, the answers become even stranger. So how does a universe end? Surprisingly, astronomers do not yet know. Unlike the Sun, whose future is understood with considerable confidence, the universe still keeps its long-term plans remarkably well hidden. At the moment, there are three leading possibilities. None of them is expected to happen anytime soon, which is reassuring. The universe appears to be in no particular hurry. The first, and currently the most widely accepted, is known as the Big Freeze, sometimes also called the heat death of the universe. Despite its rather dramatic name, almost nothing actually becomes hot. Quite the opposite. For billions upon billions of years, the universe will continue expanding. Galaxies will drift farther apart. New stars will gradually stop forming as the gas needed to create them is used up. Existing stars will slowly burn out. Even black holes may eventually evaporate through an extraordinary process known as Hawking radiation. Given enough time, the universe becomes darker, colder, and quieter, until almost nothing interesting remains to happen. The universe, in other words, does not explode. It simply loses enthusiasm. Physicists describe the Big Freeze as a state of maximum entropy. Energy still exists, but it has become so evenly distributed that nothing useful can be done with it anymore. There are no significant temperature differences, no new stars, no flowing rivers of energy capable of powering planets, biology, or civilization. Nothing catches fire. In fact, that is rather the problem. Another possibility is known as the Big Crunch. Imagine throwing a ball into the air. If gravity eventually overcomes its upward motion, the ball falls back down. Some astronomers once wondered whether the same thing might happen to the universe itself. Expansion could slow, stop, and eventually reverse. Galaxies would begin moving closer together. Temperatures would rise once again as everything collapsed inward, perhaps ending in a state strangely similar to the one from which the universe first emerged. After spending nearly 14 billion years expanding, the universe may decide that it preferred the previous floor plan. At the moment, however, observations suggest that this outcome is becoming increasingly unlikely. Rather than slowing down, the expansion of the universe appears to be accelerating. Something, most likely what we call dark energy, is pushing galaxies apart faster and faster. We still do not fully understand why, which is science's polite way of saying, we're working on it. That acceleration leads to the third possibility, the Big Rip. If dark energy were to become even stronger over time, the expansion of the universe could eventually overwhelm every force that currently holds structures together. Galaxies would separate. Then individual star systems would come apart. Planets would drift away from their stars. Eventually, even molecules, and perhaps atoms themselves, could no longer remain bound. By then, everything seems to need a little more personal space. Fortunately, current observations do not require the Big Rip either. As things stand today, the Big Freeze remains the leading explanation. But whichever ending eventually proves correct, one remarkable fact remains the same. The universe, like the stars within it, appears to have a history. And if it has a history, it may also have a future, and perhaps one day, an ending. At first, all this may sound rather depressing. The sun will one day die. The solar system will disappear. The universe itself may eventually grow cold, collapse back upon itself, or slowly tear itself apart. It is enough to make even the most optimistic astronomer reach for another cup of coffee. Perspective, however, changes everything. The universe is approximately 13.8 billion years old. The sun is about 4.6 billion years old. Modern humans have existed for only around 300,000 years. Written history covers roughly 5,000 years. Compared with the lifetime of the cosmos, human civilization has only just walked into the room. Fortunately, none of today's endings requires you to cancel tomorrow's plans. Your calendar remains reassuringly unaffected. Perhaps that is the most remarkable lesson astronomy has to offer. The universe is not a permanent place. Stars are born and die. Galaxies collide and evolve. Even space itself continues to change. Permanence was never part of the agreement. We became accustomed to timescales far shorter than those on which the universe keeps its diary. There is something strangely comforting about that. We often think that endings make things less meaningful. Perhaps they do the opposite. A sunset is beautiful precisely because it does not last forever. Seasons matter because they change. Even our own lives gain significance because time is limited. The universe may be unimaginably old, but it still reminds us that every beginning eventually becomes a history lesson. The good news is that no astronomer expects the final chapter of the universe to arrive anytime soon. There are still stars being born. Galaxies continue to shine. Planets continue to form. The cosmos remains, by every practical definition, very much open for business. For now, we occupy a remarkably fortunate moment in its history. We live while stars still shine, while galaxies still sparkle across the night sky, and while the universe remains young enough to surprise us. If anything, astronomy teaches us not to fear distant endings, but to appreciate the extraordinarily interesting chapter in which we happen to exist. In the next episode, after traveling from the possible end of everything, we will return to something much closer to home. Every culture has written stories about it. It has shaped our calendars, guided sailors across the oceans, inspired myths, frightened generations with eclipses, and even been blamed for the occasional werewolf. We will explore the moon, how it formed, why it controls Earth's tides, what really causes supermoons and blood moons, how Apollo 11 changed history, why humanity is preparing to return through the Artemis program, and why our nearest neighbor may become humanity's first stepping stone towards worlds such as Europa and Titan. This concludes Chapter 8 of The Space, The End as We Know It. Thanks for listening. See you in the next episode.